Good morning. We'll be starting the webinar, Big Data and Agile, in 1 minute. Good morning and welcome to this morning's email, Big Data and with Agile, presented by myself, Ian Abramson, and Gino Marckx. We're both from EPAM and we'd like to welcome you and thank you all for attending today. Big data, I just want to get started. It's a very exciting topic and there's a lot of hype around this area and there's a lot of reality setting in as well with this area. So I think it's really important for us to, go through and understand how big data is being used today, how Agile really helps it, and ultimately how the two together really make a solution much, much more effective and much more timely. So we're going to talk a little bit about who we are and introduce a little bit about EPAM and how myself and Hino got here. We'll talk about how data has evolved over the last little while. Big data has really been the buzzword for the last few years, but it's been around since really the web started to proliferate. And we have to look at how data is being used and how vendors and different people are addressing that. We'll talk about using big data and really understanding how science now is a real important part of what you do. This is no longer a simple BI exercise. This is not about business intelligence. This is about intelligence and predicting the future. So it's really a next step. It's an evolution to where we go. And ultimately, we're going to talk about Agile and how Agile helps big data. Agile is a wonderful methodology that pairs up really well with the scientific method and the ability to learn and collaborate. So it's a great environment for us. And then we'll finish up and talk about how, we're doing these things in the real world and some of our experiences in what we are doing in big data today and how Agile has helped us do that. So who are we? Well, I'm Ian Abramson. I'm a director here in the EPAM Toronto offices. I work as part of the BI Competency Center, and we're focused really on all things business intelligence, data warehousing, architecture, and of course, big data and data science. And that as well is part of one of the other big competency centers, which is our Advanced Learning Center. And really, that's helping us really make some leaps and bounds within the big data space.
And my name is Gino Marckx. I lead globally the Agile Competency Center for EPAM. I also am based in Toronto. And my focus these days is mostly on organizational development and long-term improvement for organizations and individuals in those organizations. And the work that I do impacts both EPAM and our customers. So who is EPAM? EPAM is a software engineering company of about 11,000 people, of which 9,300 or something like that are IT professionals or software engineers. So we have a very strong focus on the software engineering side. Most of our developers, our development centers are in Eastern Europe. The biggest one in Belarus, then Ukraine and Hungary are the next ones. But we have customers all over the world with a focus again in Europe and in North America. And we recently have expanded into Asia and Australia as well. Now, being a software engineering company and a very technological company, we obviously value those new technologies a lot, and there is an awful lot going on. And we obviously have a structure to deal with those new technologies, to learn about them, and to spread that knowledge across the organization. So we have competency centers, not unlike other organizations. We have competency centers to deal with that, our centers of excellence, if you will. And those competency centers are led typically by people who are very active in the industry and who are thought leaders in their specific domain as well. So today, there's two competency centers who are represented. Ian represents the BI Competency Center, and I myself represent the Agile Competency Center.
That's right. It's quite an exciting and very collaborative environment to work in, where we can take, the learnings of the BI Competency Center and the focus and really the experience we have, and put it together with some really senior and thought leaders in the Agile Competency Center, and help us really form a great solution for our customers. So just a quick little talk about, how data has evolved over time from, the ENIAC computers in the 40s, which were doing simple mathematical computations, and then ultimately were used during wartime to help understand and decode things. And then later, IBM developed the first definition of what business intelligence meant, and the collection of information, being able to share that information in a useful way to give people insight on their business. And of course, that then evolved into the first personal computers, which now put the computing power in people's hands. So we came from, an environment where we were data centric, and the data was now really focused in these major computers. And this was the first time that we could now bring data to the individual. And that, of course, advanced over time with, Lotus 1-2-3 coming out, and ultimately Excel, for people to start doing basic analysis and being able to collect their data. And I still, 30 years later, after spreadsheets were invented, spreadsheets are still a critical component of business functions. That eventually evolved into business intelligence tools with dashboards and advanced analytics and all these cool, neat things that allowed us now to present our insightful information in a way that was valuable to the business, such that they could focus on what was going right or what was going wrong, and see that in a very easily presented manner. And then, what happened then was, of course, the internet. And the internet has basically changed everything. And how did it change everything? It changed everything by generating information in volumes that we had never, ever seen it before. Ultimately, we needed to be able to now store masses of volumes of information that previously never happened. So something like a product like Hadoop, which created a framework for us to store mass amounts of data in a very scalable way, in a cost-effective manner. This is open source software, so everybody can basically share the basic platform and use it, and then use that in a way that now enabled data science or data mining, like really advanced mathematical models, to not just understand, well, sales have changed, but now understand why sales have changed. Was it, a factor of the weather? Was it a factor of the particular product reviews online were very negative, and that negatively impacted sales, or vice versa, that positive reviews impact sales positively? Well, these is really now, moving us into an era where all information could be analyzed from all aspects, to not just provide value, but provide customization, to individualize things to people. So because I understand the entire population, if I understand you, I can now individualize, an offer, medical treatment to your needs based on what was successful in the past. So why big data, right? You've all heard the hype. You all heard about that this is the next generation. Well, it is absolutely the next generation. And I go, I know it's mainstream when Dilbert starts writing about it, right? That we now have all this information, but the problem is, what are we going to do with it? So we have, we remember the V's of big data: velocity, volume, and variety, right? Those are three key elements of what we need to deal with. So we need systems that can now address that. Even our existing data system, our existing data warehouse are bigger demands are putting on it. So we're looking at bigger and bigger hardware, or appliance hardware, to be able to meet the capacity and even the computing volume that's required. So one of the options is archiving data from our data warehouse, but that ends up putting it into a place that's too far and I can't use in my analysis. I remember working for a telecom company, and we were lucky when we were able to put 1 month of call detail records online available for query. But the thought of putting 20 years of those calls was just not even considered because it was just too much for the hardware at the time to deal with. But now I've got hardware that I can deal with in a much more effective way. So now I can retain all my data for all analysis and make it available in a business hub that really provides that value to the users. So what is it about? Now, a lot of people talk about big data, and I can tell you that 50% of big data projects fail, and they fail for one basic reason. They don't make an impact. They don't make a difference. What happens is a lot of organizations try to boil the ocean without looking at the key business question that they want to answer. I want to increase sales by 1%, and I'm going to do that by knowing what factors impact those sales so that I can better prepare and minimize out of stocks. So those would make an impact in sales. Or I want to provide online a better recommendation engine to my consumers. So the example of that is a company like Nordstrom. So Nordstrom has a big data team of data scientists and technologists who together create data-driven products to delight their customers. And I think that's a key factor, is that using data now to delight their customers. So they've used data in helping the in-store brick and mortar experience now come to the online experience. And they've done that through some very interesting and creative ways, which we could talk about all day, but let's just focus on Agile today. So we have a new architecture, right? The whole idea is that I want to be able to collect all these data sources that you see on the left-hand side of the screen and collect it into a single scalable repository that allows me to have it organized for then consumption within operational data stores or a data warehouse or analytics platform. And it also provides a platform for us to be able to, archive data and be able to have a great platform that's integrated and services up information to the entire organization. What it also gives you is a sandbox, a place where data scientists can now exercise and really start thinking about what information, what kind of predictions can they do, because they have this information available. Maybe we need some additional information, but I have an environment which does will support very complex mathematics in a very large environment. And that together, ultimately will provide a very robust platform to do that. So taking it from the idea of that we have all this data, the skills in our approach have to change. We can't, take a business intelligence Cognos developer and say, you're a data scientist now. That's not the way it works. A data scientist has many skills beyond even what the basic business analyst or business intelligence developer will have. They have obviously things like domain experience like them. They have some data engineering. But we have to start introducing things like the scientific method, the idea that we're going to test a problem, we're going to define a problem, we're going to test it, and then we're going to iterate around that problem to perfect it. We need to have skills in mathematics and statistics. I graduated in applied mathematics 25 years ago, and I remember all my statistics back then. And it's interesting to see that here I am 25 years later, and it's all coming back to me. And I have to, revisit my linear regressions or nonlinear regressions, or, what correlation coefficients am I going to be using, and whether or not correlation R-squareds are valid, and whether or not this test is valid to interpret those results. So I have to have that kind of expertise and statistics and background in that to be able to interpret them. We have to have the ability to visualize, and visualization and hackers are kind of beside each other, because you have to have that ability and openness to be able to pursue new tools, new techniques, new models. So visualization, sure, Excel is one option for you, and we've been using that for some of the reporting, but then you look at tools like Gephi or other tools. Really that provide you, even more customizable vector type graphics and very cool. So you have to be open to do visualizations and imagine how we can better visualize it. And, at the end of that, it's a bunch of skills. This is not one person. I don't think there's any one person in the world. Well, maybe there's one, but there's very few people in the world that have all of these skills together. But the reality is this is a team of data scientists, and they will each have some knowledge of each of these components, but they will each be strong and together create that collaborative team. And that, again, is why Agile helps, because it creates that collaboration. It forces that collaboration. And then, just to extend that is, how do I approach problems now is with the scientific method. I want to state a problem. I want to understand how my business, what the question is, what is the problem I want to solve. I need to understand or create better recommendations to improve the sales on my e-commerce site. Well, that's a great problem. We're going to do that by doing a better recommendation engine, which have recommendations that are better aligned with the individuals who are logged onto the website. And we create those models, we test them, we then determine the results, and then determine whether or not we should reiterate, maybe with additional data sources, maybe even with additional maybe just to refine the model, to make a better result, to make a better use within the organization. And then, like I said, it's all about the use case. So when we're doing big data, don't boil the ocean. Have a specific use case. I'm showing here, just an example of some of the things and characteristics of a use case that you need to define. And again, it's aligned with, the big data and Agile. So this is from Alistair Coburn, who's one of the writers of the Agile Manifesto. And he really captures the important things that we need to understand, which is, what is the question and what is the success factor? How do we get from A to B so that I understand it and who will be involved? And then on the right side, I give you a whole bunch of different technology use cases. Again, this is about focus. Have some focus criteria that allows you to create a picture, because then you can start looking at using Agile to really provide the infrastructure or the framework in which to be successful.
Yes. So now we have introduced a little bit about big data. We talked a little bit about where it comes from and so forth. Let's talk a little bit about what the process went through as well, what the process evolutions were too. So initially in the 40s, when we did software engineering, we were really writing software to solve a specific problem. It was problem-centric approach, very much like data-centric approach in the early days for data. And right now, we also have moved to a user-centric approach. And the reason why that is that initially the software was written by the people who used it, or specified at least also by the people who use it. And right now, the people who use software, because software became a lot more mainstream, the people who use software do not necessarily write it anymore or don't specify it necessarily anymore. So there is a much bigger gap between who writes it, who specifies it, and who uses the software. Now, it's not only that. Also, we have, because of those different users and because of the user-centric approach right now, we have different departments that all have input to the same software solution. It's solving multiple problems at the same time. That also means that those different departments need to work together. That also means that the gap there again becomes bigger, and we no longer can predict what the impact is of the software that we write on our users, whether our users will like it, whether we write the right functionality that they expect, and so forth, whether we're actually solving their problems, and so forth. So the best way to deal with that, and a lot of people in the industry have realized that, is to basically come up with a couple of validations of our assumptions as early as we possibly can. Instead of assuming that we're building the right software, let's just build a piece of that functionality and ask our customers whether or not they are actually using it. Instead of assuming that we know all the technology and all the technological hurdles that we will need to go through, let's just build a piece of functionality through all the layers of our infrastructure so that we get the feedback from the actual system. Instead of assuming that we know everything, let's get some validation early on. And that's really what all those methods are trying to do. So when we talk about the manufacturing side, Six Sigma, for instance, is a process that is introduced by Motorola in the mid-'80s, but ultimately comes from the Toyota production system, which was introduced late 40s and has been developed since, and which led to lean and so forth. And that is a very strong influencer of the agile methods. And also already in the mid 90s, Scrum, the most popular agile method, if you will, was introduced by Ken Schwaber and Jeff Sutherland writing a paper. And at the end of the 90s, you had extreme programming that was introduced by Ken Beck. And it was in the early 2000s that all of those things came together in the Agile Manifesto. So Agile has been around for quite some time, and the only reason why we were able to get that feedback and validate those assumptions early on is because of the changes in technology as well. You can imagine that for the ENIAC, for instance, where it took 2 weeks or a couple of weeks to turn a piece of software that was written on a piece of paper into a working program, it was not that easy to get fast feedback. Nowadays, we compile our programs in a couple of seconds. We run thousands and thousands of tests in a couple of minutes, sometimes in hours, depending on the infrastructure that you use. And we already get this feedback way faster. So all of these methods use that new technology, use the collaboration between the different users, between the different parties involved, the database experts, the developers, the testers, and so forth, business analysts, but also uses the collaboration between different departments to come up with software that's built the right way, but also that we build the right software that has this impact that Ian was talking about earlier on. So this is what came out of that evolution, the Agile Manifesto, which is basically the foundation of any Agile method out there. As you see, there is no guidance in here on how to write software. This is not a set of tools and practices that teaches you how to write software. It really is a principle-based system. And those principles and those values you can use and you can implement depending on your context, right? So let's see how that really works in the industry, and let's see how that works compared to a classic delivery approach. When you look at classic delivery, and this is some kind of a timeline, you try to implement something, and by the end you basically have a release date. What you do is you first start planning the software that you create. You plan to build the functionality that you expect your customers to need and to use, and you plan also assuming that you know all the technological hurdles that you will go through. But really, when you really have feedback on your plan, whether or not you planned the right way, you took all the risks into account, you had the right people assigned to your project, all of those kinds of things. The first time that you really get feedback is when you release to production. That's when you know whether you or not you hit the date. That's when you know whether or not you hit the scope and you build everything that your customers needed. So the second thing that you do is coming up with those requirements. Basically, thinking really hard what our customers would need, what they would value, and again, the first time that we really know whether or not we thought about the right functionality and we're building the right functionality is all the way in the end, when we give the software to our users and we actually put it in their hands. And we can go on like that. We have architecture, and really the first time that your architecture is validated and all the assumptions that you've made that inform the decisions for your architecture are only validated when you integrate that piece of software with your backend systems and with the rest of your organization. And then the design, the how you write your code and how different components talk together and so on is validated when you actually have your code, right? So your UML designs and all of those kinds of things is only validated then, and your code itself is validated during the testing phase. And that is a classic approach of writing software. We first plan, we do the requirements architecture. There might be a couple of steps in between there as well, all the way to the end. But you see that you really have to wait until the end to know whether or not you build the right product, to know whether or not your product will have an impact on your user base. And when something happens, when you got a situation in the end, you find a bug or you find some kind of problem with one of those assumptions that you made, and the decision turns out to be the wrong decision, then you potentially have to go back all the way to the front, and all of the work that you've done since then might be impacted and might need to be redone, right? Hopefully it's not that bad, and you can do it with a couple of changes in each and every stage, but typically there's an awful lot of impact. Now, what happens in an Agile approach is, as I said, we really want to be adaptive. We really want to learn fast. We really want to use the power of the feedback that has been given to us by the technology evolution. What we're doing is we still plan. We still try to figure out what we're going to build by the end of the day. But we try to split the functionality up into pieces that can be delivered independently. So instead of going through an entire phase of requirements and stacking up all these assumptions that we have made, instead of going through the entire phase of architecture and so forth, what we're actually doing is we build a we actually get the requirements for a small piece of our functionality. We build the architecture to support that functionality, the design to support that code that implements that functionality and so forth. And we all do that until we have something that is releasable. Maybe not useful for our end users, but releasable at least internally so we can get the feedback. And with that feedback, we already validate our internal plan, our small plan, the plan for this iteration, if you want to call it that way, alone. We also validate our requirements. Is this really what our users expected? Is this really what they wanted? We validate whether or not our architecture supports the code that we need to write, and so on. But we do more than that. We also validate the initial plan and the overall plan that we came up with in the beginning. And we keep on, because what we're actually doing is in building this piece of functionality, we have a finished product, or at least part of a finished product. And it's a lot easier based on those actual data to know whether or not you will reach your final deadline. And if you can reach it, this is the time to still change, and this is a time where you can still impact the rest of your plan. So you keep on doing that, and you keep on getting feedback on your requirements, on your new incremental architecture design and so forth, and also on your plan. And when something goes wrong completely in the end, instead of having to go all the way to the front, and instead of having to redesign your architecture, redo your design, redo parts of your code, you only need to do it for the piece that you're actually working on. So what you're doing is you're making the risk a lot smaller by validating your assumptions that you made that led to the decisions that you made in your code, in your architecture, in your design, and so forth, by validating that a lot earlier. And really what you're doing is you're using Agile as an early learning strategy. And Alistair Coburn, and Ian mentioned him already, really has good stuff and has done some good work in that area to make that clear, that Agile really can be used as an early learning strategy. What we don't know in the beginning is, are we actually building the right thing? Are we building the software that our customers need? The people that we have, the team that we have, do they have the right skills to do that work? We will learn that along the way just by going through the entire, through all the layers of the architecture, making sure that we have an end product at every iteration boundary. Will our solution work? Will it integrate with the backend systems? Do we really understand how it all works? Do we understand what the cost is? Do we understand what those risks are, and so forth? So really, Agile is an early learning strategy, which maps really well to big data, especially when you look at the scientific method. That you don't know what you don't know, and trying to validate that up front is really what you're trying to achieve. So that's where the perfect marriage between Agile and big data comes from, right? So when you look at a couple of the main characteristics of both technologies, then on the big data side, you have the complex data that you have to deal with, and you have the scientific method really that allows your data scientists to build hypotheses and prove those hypotheses or disprove them. Well, Agile allows you to do that very quickly by providing you that ability to give fast feedback. And also the iterations allow you to quickly change direction if you need to. It's an adaptive process. The impact that you're trying to generate with the big data is something that aligns really well with the value-driven approach that Agile methods really provide. Agile is trying to build the highest value software first, so that the customers really get a high return on investment. So that impact that Ian was talking about is really supported by those methods. And obviously discovery, which is very important in big data projects, in data science. You discover what information you can get. You discover whether or not some hypotheses work and some don't. Is something that aligns really well with the discovery that you have in your Agile approaches as well. If I want to refer back to Agile as an early learning strategy, this is really what you're doing. You're discovering whether or not your team is capable of building that software, discovering whether or not the functionality that you came up with is the one that your users need, and so forth. So this is really, really aligned.
Absolutely, it's great. It's interesting to see how well Agile has helped us out. Coming from a background in data warehousing and waterfall, the risk was always that the Big Bang uh, development caused really problems, and that you could work for 6 months and hope to deliver something of value, and that was what it was. It was a hope. You never knew. So what's Agile really helping us with is really the high degree of collaboration that we get between developers, users, stakeholders, and all the experts. Everybody contributes to the overall team, and ensuring that the team is producing the right thing and making the right impact. The concept of early and frequent software. So, that is so important. That's the whole idea of the iteration, right? I create an experiment, I test that experiment, I look at the results, and I can then understand whether or not those results are valuable. Should I, change my method? Should I change from a linear regression to a nonlinear regression? Should I change to other mathematical techniques? Those are things that we can then evaluate because we have the working software. We know how good it is. How close is it to being perfect, or how close is it to being great? Obviously, great emphasis on collaboration. I can't go into that how important, the work between the business as well as the big data science team is going to be valuable, right? And this is really about adapting to change. We work in a technology where change, there's the chat. Where change has to be embraced, right? Because we're going to learn from this and learn from the methods of the past to be able to do that. So, I think that the idea is here, big data really benefits from what Agile gives it.
Yeah, and it wouldn't be a good marriage if there is no benefit on both sides, right? So Agile also benefits from big data. As I mentioned already, Agile is actually trying to do two things. The first thing that it's trying to do, well, not necessarily in order though. So the first thing that it's trying to do is building the right software. Building software that is valuable, that creates an impact for your users. But the second thing that it's trying to do is building the software in the right way, that it's high quality and so forth, that you have sustainable pace and you can sustainably add value going forward. Now, building the right product, knowing what your customers really need, is something that big data projects and big and data science can help us with. Right now, all of the burden to figure out what the right software is on the shoulders of typically one person called a product owner or a customer in XP, depending on which methods you use. And those people need to figure out what is the functionality that needs to go in our product. What is the priority with which we want to put that functionality in? What are the small details on how we implement that piece of functionality? Do we put it in screen A or do we put it in screen B? All of those things right now are on the shoulders of typically one person to make the final call. If we have that big data analysis and we really get the feedback from the people in the industry, get the feedback from the social media and so forth, we can help this product owner to make decisions based on the real user base instead of only based on their assumptions. So Agile can definitely benefit from big data as well.
Great. Thanks, That's absolutely right. And this is an example of something similar to what we've done in the past for a retailer to understand what factors were impacting sales. And this is to demonstrate how we aligned this, our construction of our model along with the way that Agile works, right? So we collected a whole bunch of information in various sprints, and then we looked actually at individual factors that affect sales, things like the demographics of an area, the whether or not a competitor exists, the weather. So if we need to sell shovels or I need to sell winter jackets, I need to understand that. Do I need to sell rain gear? What's the inventory in a store so that we can understand, is there a problem with supply chain and that's causing, potentially lost sales? Social data. How can I collect social data and understand how people are talking? What's the buzz about my organization to help us to really look at, what people are saying about us so that I can then figure out what other things. And then I have a TPD. So basically, this was the idea that we looked at individual factors. So we added one factor, we created the regression, the correlation model, and looked at whether or not demographics correlated to changes in sales. Or we looked at competitor density of how, when new competitors moved into the area. So the model kept changing and evolving. And each piece really provided, us to build on the previous one. So one factor may not have been as successful. It may not have shown correlation within that many products, where another one will show a huge correlation, and we can explain a lot of the sale change based on a particular factor. So we learn which factors tend to have more impact, ones that have less impact. And through this type of an iteration where we can kind of practice and improve our process of loading data, modeling data, and then ultimately presenting that data and integrating it into our business plan, that really it helps us. And obviously the core collaboration is what will help, ultimately that succeed even better, because as we prove to the business, we can start explaining why these things are happening. The business then is more accepting to the data science team, being able to say, here's what's happening, here's why it's happening, and now we should take this action to be able to solve it. So it's the scouting report of how to make sure that we are prepared, for whatever battle we have to battle. So where ultimately is data going to go, right? The digital data ecosystem is changing faster. We hear it all of how much data is coming in and how much information we need to deal with. The problem is, obviously, there is bad data. There are challenges that we have. So can we get to a point of having all data in a repository, an enterprise data hub? I think that's an achievable goal for us. We have experience in being able to, help customers initialize that and be able to, create an environment that is very robust and allows them to really see the value in that data organized through the central hub. And we do need all the data. A company like Akamai who streams videos, they analyze 75 million events a day to help better target not just advertising, but even the services in the back end to ensure that they have the platforms and have information where they need it. The other thing too is big data is going to complement your data warehouse. This is not a replacement to an existing data warehouse. Big data today does not do, individual analytics very well. It does set analytics and large data analytics really well. But to do the things that data warehouses do, which is focused on insightful reporting, that happens really within your data warehouse. Big data may even feed information to your data warehouse based on the models that we create, and then we can use that within our data warehouse environments. And data access today is hard. It's complicated. If you're going to be accessing big data, well, there aren't a lot of tools that do it very effectively, and you need to look at, being able to code and things like MapReduce to be able to really do that. So access is not as hard, and it's complex, and there's data that's spread out all over the place. So we really need an environment that's going to help make that easy. And obviously, get ready for change, because you should be well aware that the amount of venture capital money being spent in big data is just in the billions of dollars right now, and this is an environment that's changing, it's evolving, it's maturing, and really is starting to deal with the challenges we've had in a very effective way. There are tools that are popping up every day that are more effective than the tools we had yesterday. So again, you have to embrace the change. If you're not working in an environment like Agile, chaos is going to cause chaos. You have to have a framework that's going to allow you to really manage that effectively. So, like I said, why does it help us? It's incremental development, right? The idea of I do my data and my reporting streams. I have those two teams working in tandem and supporting each other and helping each other. It helps identify any problems or challenges we have earlier in the process. So we identified security issues and things like that. So what do you need to do? What is disaster recovery, and how does that help me in the future? How am I going to load data more effectively? And ultimately, supporting the scientific method to generate new ideas based on real results, right? The idea of creating working software and being able to create your design as it's happening is what it's all about, is having that flexibility to really meet needs and change and adapt and do it based on learnings. Don't do it based on guessing, right? This is not a system where we're going to guess. We are going to theorize. We are going to now be scientists. We are not going to be simply data jockeys. We're going to be data scientists. I think that's important. So, what have we done? And this is a bit of the EPAM story about some real world use cases, right? So here was a problem where we had a oil and gas vendor who wanted to collect additional information off of their sensors. They were, in their traditional data warehouse, they were limited. Like I said to you before in telecom, the telecom industry was limited by technology to see how many records they could have on available and online to be able to do data analysis. Well, by so it was limited. So the same thing with these oil and gas companies where they were limited to some of the key sensors on each of their platforms and collected that data. But the idea was if we collected all data, if we collected data from all platforms, does that provide us additional value? Can we start looking at doing failure analysis on parts that we maybe hadn't looked at before? Maybe there are other factors that are impacting the operations. So that was really an idea of creating an environment where we can collect all data, not just the data that was currently going to the data warehouse. Another use case that's very common today is how do I offload some of the stuff that's going on my existing data warehouse? So like I said to you earlier, we're running out of space on our data warehouses. So what's that forcing us to do and forcing the database manufacturers to do? Is forcing us to buy new hardware, buy bigger hardware, buy more expensive hardware. But if I could have a scalable archive solution that brings my data, or keeps my data in a near-line storage, is that valuable to me? Of course it is, because if I take load off the data warehouse, if I move the data that's rarely used into Hadoop or a NoSQL environment that allows us to, query it, but maybe not at a speed we need, but also to do long-range analysis, that's really valuable. So this was a one particular organization that was collecting, 200 terabytes a day, so it was becoming a big issue. Or 200 terabytes were in Hadoop and they were collecting 100 a day. So it was becoming a big issue, and how do we manage that? And this was a solution where we helped them to manage that. This is another thing. This is online. This is about collecting a lot of information from the web and having that information be usable and allow it to then customize the experience for users. In this case, it was an mobile advertising framework that we helped to create, and using Hadoop and MongoDB and MicroStrategy to create the reports and be able to provide that insight into information, as well as be able to predict that based on a new user coming in, this is what we should be customizing for them. Again, it's the individualized and customized experience of big data that only big data can provide. That's not something that data warehouses have been able to do up till this point. And then this is one where we are working with one of the larger retailers here and collecting a lot of information that they previously had splintered around the organization in some legacy systems, in the current EDW, and maybe in other systems, and be able to bring that together and be able to help them really modernize some of the analytics that they do and look at, analytics over time that they never had been able to do. So this was a case of, where we had collected 7 to 8 years of point of sales data, where in the past they were analyzing 1 or 2 years. So, we're giving them a much longer time horizon, and we're doing clustering to help support the recommendation engines on their e-commerce site. And we're using a variety of tools, like I said, Gephi for visualizations. We use R for analytics. So if you're using a tool like SAS, well, there's a tool out there called R that's integrated very well with Hadoop and allows you to do some very advanced mathematical analysis, and obviously supporting a pretty wide and fair variety of different platforms. And then finally, we have another one, which is called Info Engine, which collects and kind of collates a whole bunch of information from around the globe, around the web, and then allows each of these customers that we have to customize newsletters and such, so that they can get focused data just on what they want, and they don't have to go out and look for it. And it's very focused on keywords and very adaptable and customizable to what each of the customers do. So that kind of brings us to the end of what we had to say. We're going to be taking questions. If you want to put that into the chat box, I think that would work. And basically the idea here uh, was that big data can help predict things. It can help people in the future, but really to enable big data is something like an agile framework, which really allows us to create that collaborative environment and and one of results, not just of guessing, but building on what we've done and building on things to get better. That and so that's where we are, and that's kind of what big data is about. Did you
Yes.
want to kind of close anything, Hino?
No, I mean, I think that we talked about it already, right? That Agile really supports big data in doing this data science and using the scientific method. And on the other hand, as well, that big data is very useful for Agile projects to figure out what software we really need to build. Um, so I think we covered it. So if there's any questions, um, I'm not sure, Alina, if we answered your question in one of the previous slides, especially with the real life examples.
So absolutely, there's a question out there. Could we please talk about some of the real world examples of ROI? And one of them that we have is from Nordstrom's, who changed the way they did their recommendation engine, as I kind of talked about earlier, right? Nordstrom's, what they had done, and this is really this was Nordstrom's wanted to change the way that the online experience was to the customer. One of the things that Nordstrom's features is in-store shoppers. So these are, um, designers or people who are fashion savvy more so than myself and Hino, and can recommend outfits and a total look for an individual. So that's obviously a very successful program which they have. So how can I take that program and bring that program to the web? Well, when we bring it to the web, how do we do it? Well, we create a recommendation engines, right? And that recommendation engine is fed instead of by merchandisers who say, well, if a man goes in, he'll buy a shirt, and when he buys a shirt, he probably needs a pair of pants and a tie, as well as maybe a belt and shoes. And that seems very intuitive to most people. But as a man, I know that's not the way men shop. I don't go online and buy a whole outfit. Men buy things really around, I'm going to go in and buy a shirt. Well, I'm probably going to buy 5 shirts that day. That's the customized experience I want. So show me 5 shirts that are similar to the shirt I like, but are fashionable. So if I would have gone shopping with a personal shopper, this is what they would have shown. Or outfits in the case of female shoppers, where not just I'm buying a red top. Well, find patterns that are similar, and these are items that were bought together by personal shoppers. So what did that cause? They were able to see a 6 to 8% increase in their online sales as a result directly of the change in the recommendation engine. They did that through A/B testing so they could measure it. So obviously, again, advanced testing techniques are required. Advanced math techniques are required to kind of model it, and then ultimately it provides the value, which is the impact.
So next question that we have is we spoke about big oil. What examples do we have in Calgary or in Canada in general?
It would mainly we work with one primarily U.S. Gas company who's primarily out of the U.S. but also has a Canadian practice.
Yeah. And so there's a next question there. So it's not the case though that we don't work with customers in Canada. It's just not that we work with customers, specific Canadian customers who are into the big oil.
We're open to that though.
Yeah, we are.
Yeah.
So next question is: I understand the link between Agile and big data that you're suggesting. However, are there any circumstances in which Agile would not be the appropriate methodology? So are there any circumstances in which Agile would not be the appropriate methodology? Are we talking about big data specifically, big data projects, or are we talking about other kinds of projects?
I think in the case of big data, could you work in a waterfall? I expect we could, but what we're finding is that, having, using Agile provides me a couple of things. Obviously the collaboration, obviously the value that it brings, but it also brings me that concept of the backlog. And the backlog is so important to us. It's, I can't do everything at the same time. And, I'm not going to build all my requirements because I don't know all my questions. I don't know all my answers. I don't know exactly what my destination is yet. So if my architecture is not flexible, if my approach is not flexible, I think we have a real challenge to keep that in alignment. Yes, I guess individually within a use case, you could build that use case as a waterfall, but then you're going to have iterations. You're going to have iterations even there. So you're going to use components of it. I think the only time I wouldn't use it is probably if an organization is completely resistant to opening up to that.
Yep.
But then I'd be concerned whether or not they're even resistant to opening up to big data and seeing the value that it could bring.
And let me drag it a little bit out of the big data sphere. So, are there any projects or any situations where agile would not be advisable? Personally, I don't find any, and I've been asked that question an awful lot of times. I don't really find any because the only thing that you're doing is you're trying to learn early and you're trying to validate your assumptions early. Now, one of the consequences that you get by trying to validate the assumptions early is that sometimes you do a tiny bit more work up front that you have to rework later on. So if you are in a situation where you actually can predict every single thing that will happen on your software project, where you can predict every single decision that you need to make, and you're absolutely certain that those decisions are the right decisions, yeah, by all means, use waterfall, and it will probably be cheaper. But the situations that I know of where all of that information is available are very few, if at all, if any at all.
It's an evolution in project management, I think,
Exactly.
in how we approach projects. So, if you believe in agile, is there a case where you think it doesn't work? Well, I think, our case is we think it does work.
So there is another question as well, and that question is about. Whoops.
There was one before that.
There's one before that, so let's go for that first. What about the case that the data itself has a change that affects the core of our software?
I'm not really sure I understand that. If data changes, I think that, we have to adapt, right? So, there is a case, maybe the inbound data is going to change, the messaging format changes. I think we have to adapt to that and we have to realize that could happen. The software itself, well, a new version of Cloudera will come out, or a new version of Hadoop, or MapR, or Talend, or one of the pieces of software that we're going to be working with, and there's obviously the ability to adapt to that. I think that the idea is create an infrastructure that adapts to change and realize that big data is not perfect on the software side either. So you will have to adapt on your software side. You may have to find tools that are more appropriate than what you originally thought. Tools may not work together as you expect. So, when we have a case where we're storing data in files called Avro, and Avro has a problem talking to Impala, which is a tool that Cloudera provides for fast SQL access. So I think that, we have to adapt to that, and we have to look at how to get around that. Maybe it's the next release, but it's all about adapting, and I think it's adapting on both sides.
Yeah, I agree. It really is all about adapting, and really when you find data, and let's say that you're in the middle of a project and you find that the data that you need to work with is a totally different model as the data that you imagine up front, yeah, you might need to change a couple of things. But let's consider a different approach. Let's consider an approach where you plan everything up front and you do the architecture and the design and all of those things, and you validate only in the end. You will have challenges in changing your software project as well. You'll have to go back all the way to your architecture and change that, and the impact will be gigantic. What Agile does and what it actually promotes is to build systems, as Ian says, that are adaptable to that kind of change. Right? If you need to change your infrastructure, then you will be able to do that to some degree. Obviously, it will cost you. It will cost you time. It will cost you energy to go through those changes. But at the same time, you will have you will be able to do it while you already have part of your application running. You already get that return on investment. While in a waterfall-ish approach or in a phased approach, I prefer to call it, you would not have any value yet, and you would still need to do all that refactoring and that re-engineering. So there's a next question that is, how big is the big data market actually in Canada?
Well, I think that's a question which I can't accurately answer. I can only tell it based on our observations. And basically, most of the customers that we have are talking about big data. I think big data does lag a little bit over the US. I think that uh, big data in the US, the techniques, the people who have embraced it are the leaders out there. I think that Canada and Canadian organizations tend to play it a little bit safer. Uh, Maybe it's just the Canadian way. But I think that they're losing opportunity. It's not a nice to have anymore. You need to find a way to embrace it. This is not, this is not a simple extension of your BI infrastructure. This is a change to the way you're going to do data, the way you're going to do analysis, and the way you're going to make an impact. Right. This is about bringing information together and finding competitive advantage that you never had before. So, I've been to customers and they tell me they throw away 80%, they throw away 60% of their data. Well, there is value in that stuff that they're throwing away and they're losing it, and the idea of unstructured data, well, that's the next evolution, right? We're very good at analyzing structured data. Well, organizations should be very good at analyzing structured data, or again, they're losing competitive advantages. There's a difference between the companies that are leading in this field versus the companies that are lagging. And there's a reason why Amazon is so far ahead in terms of e-retailing than everybody else, and how their recommendation engine works, and how they use data to drive information and value. And sell advertising. That's all done through big data initiatives on these websites. And the bricks and mortar organizations have to start embracing that and bring that experience of the web to even the bricks and mortar. So I don't think it's just a nice to have. I think this is a must to have. It's not often that we have revolutionary ideas to change and make such an impact. Data warehousing is 30, 40, 50 years old. And it's pretty much the same. If I go back and look at IBM's original document that stated how it's done, it's still pretty much the same. Well, big data, though, has changed significantly how we have to deal with data and how we have to analyze it. So I think it's really important.
So we did you answer that question?
Yeah, I think so.
Oh, okay. So the last question was basically about the challenges about bringing together multiple sources, structured and unstructured data from different areas.
Right. So that's a challenge, and it's going to be a challenge that you're going to have. The great value that Hadoop brings is that it can store any form of data in a very scalable way. So if I want to store images, if I want to store files, if I want to store data, if I want to encrypt data, I have that ability, and then be able to access it through let's call it a common set of tools. And those tools provide access. And you're going to use things in the proper way, and you're going to access, whether it's unstructured web clickstream data versus and social data versus, my point of sales information. So all of that information is valuable. We are able to store it together. And then the challenge becomes, how do I integrate it? How do I know this web click is this customer and triangulate? And that becomes a question not only of how do I do it, which is very doable today, but whether or not I'm also dealing with privacy issues now, because you see the news every day, right? Of if I have all this information, I can customize your experience. Well, people are saying I don't want a customized experience. Well, I can tell you, cancer patients want to know that if I have customized cancer care that is going to be the most successful based on my symptoms and based on the experience of all the previous patients before me, that to me is valuable and doesn't deal with privacy. But it seems like when we're on a website, we get into this privacy issue. So I think that the idea is that Hadoop creates the environment that allows you to have all that data together, both structured and unstructured, and provide you a facility that allows you to get it out.
Right. But it's still challenging, obviously.
Oh, absolutely a challenge to integrate. This is not a simple project. That's why you need all of those skills that I talked about, because those skills are what's going to help you solve the problems and help you integrate it. It is not a simple problem. This is a complex problem, and you need smart people to help solve your complex problem.
Right. So I think this concludes the webinar. I think we spent all the time that we had available. And so thank you so much for attending, and thank you so much for the questions in the end. I hope it was valuable for all of you. And should you have any more questions later on, then please feel free to contact us. And Yeah. Anything else, Ian?
No, that's it. Thank you very much for your time today, and congratulations to Canada on another gold medal.
Bye bye.
Thank you.